Okay, sorry. Here we go. All right. So we've got our words there that we're looking for, right? And we want to try and match these things up. So we have this symbol, right? And we're saying that is less than, right? So less than means is less than. And did anyone get one of the other phrases here? So for this symbol, did any of these other phrases match besides is less than? What other? I'll give you a hint. There's one more phrase that goes with this here. Okay. Is at least. Okay. So I think, are you seeing, like, you see the word less, you see the word least, and you're like, okay. So it's not is at least. Let me see if I can try and figure that out here for you here. So let's say it this way, right? If I put up on the board here 2 is less than 3, that's a true statement, right? If we hear it, 2 is less than 3, we see it, it's true, right? If we say 2 is at least 3, is that still true? Is 2 is at least 3? Is that true? No. 2 is smaller than 3. At least 3 would mean what? 3 or more. So is at least should go for what symbol? If it's 3 or more, what's the symbol for that? Greater than or equal to. So is at least turns out to be greater than or equal to. So I'm going to put a greater than here. I'll put a less than or equal to here. And then greater than or equal to. So greater than or equal to is an is at least. Okay, that phrase right there. Okay, so maybe we should do it that way. Let me zoom out some here so we can fit them all on here. There we go. Okay. So maybe we should just go through it this way. Okay. No, I'll keep going here. So again, that less than, there's one other phrase up here that's less than. But maybe we should skip it and come back. Okay? So let's try this next one right here. What's this symbol mean? What's this symbol mean? Is greater than, okay? And we have that here. Okay, is greater than. I have it right there, number 1. Okay, is greater than. Does anyone think they have another phrase that goes with is greater than? Okay, yes. Okay, so greater than or equal to, that'll go for this one though, right? Because this one doesn't have the equal to sign. So we're going to put this one right here. Is greater than, okay, or equal to. Okay, is greater than or equal to. All right. Matt and Danny. Yeah, that wasn't it. Go on. Yeah. Guys, you can try and pull one over Mr. Whitmire, but he's not, he's dumb, but he's not that dumb, okay? So anyway, moving on, okay? So let's see here. We've got is greater than, we have is at least, we have is greater than or equal to, okay? What about this symbol? What's this symbol's name? Is less than or equal to. Okay, so we took care of number 3. All right, so now we get to those more tricky ones. Oh, we also did is less than as well. So we have 5, 6, and 7 there to deal with. Is at most. Is at most. Okay, so is at most is less than or equal to, right? You can also be equal to it. If you're at most, for example, if you weigh at most 100 pounds, you could be 100 pounds or less than 100 pounds, right? Is at most. So that's going to be less than or equal to here. Okay, so that took care of is at most. Is no more than. And actually, I think, now I'm thinking about it, I think this less than and greater than only have one that I wrote up here. They each only have one. So these both are going to go for the equal to's as well, I think. So is no more than. Is no more than. So if you can have no more than 10 people in a room, if you can have no more than 10 people in a room, what inequality symbol is that? Less than or equal to. That's right. So less than or equal to is no more than. Okay, is no more than. Okay, and if you can have no less, if you can have no less, so let's say maybe to pass a class, you can have no less than a 60, right? You can have no less than a 60 to pass a class. What would that mean then? Your grade has to be which symbol? Greater than or equal to 60. So is no less than. Okay. So we are going to be using these phrases today when we talk about solving inequality word problems. Okay, we're going to be talking about those phrases today. So keep this nearby. All right, keep this nearby. We're going to be talking about this. But before we talk about those word problems, I forgot I wanted to go over the homework. Okay, so let's take a look at those homework problems and see here. Okay, how we did. Started on there's 3, 5, and 7. Oops, I forgot to circle 7. The answer for 7. And for 9. And for 11. There we go. So I showed all my work there. I showed all my work. Okay, I showed all my work. 3, 5, and 7. And of course the graphs too, right? Making sure you have either the open dot or the closed dot, right? Open dots if they don't have the equal to, filled in dots if they do have the equal to. Okay. If you have trouble knowing which way to shade, okay, so maybe you can find the dot, no problem. Right? The dot is just the number, whatever your number is. If you're having trouble knowing which way to shade, you can pick another number on your number line. So for example, here for number 7. Okay? I'll be right with you one sec there, Ben. Number 7, if 6, n is less than 6, you put 6 there, open circle, and then pick a number. Pick 7. Plug 7 into the inequality. Is 7 less than 6? No. And so you would not shade in this direction, you would shade in the opposite direction. Okay? Pick 5. 5, is that less than 6? Yes. So you shade in the direction of 5 there. Okay? You can test it to see. Sorry, Ben, what was your question?
I was going to say, we only have to do 3, 5, 7, 9, 11,
and then,
15.
yep. Mm-hmm.
Oh, then I did do this. I did this yesterday.
Oh, okay. My apologies. Yeah, that was just bad.
I didn't
Mine maybe looked a little bit different, that's all. So, yeah. I got you credit then, bud. All right, there's 9, 11 on the bottom there. Okay, 9 and 11. And then here's number 15 on the back. Okay, 15, you wanted to, because you had that big fraction bar there, you wanted to multiply both sides by 15 first. Okay, we're multiplying by a positive 15 here, so the sign stays the same direction. And then you add 11 to both sides, and then you have n by itself right there. N is less than -4. Okay. Remember, it's when you multiply by a negative, or when you divide by a negative. That's when you flip the sign around. Okay? We don't flip the sign around if the number's already negative and we're multiplying by positive. Okay? We don't. Only when you're dividing by or multiplying by a negative. Alrighty? Questions on any of that? Okay. I have one other thing I want to show you before we talk about those word problems too. And actually, I'm going to show it to you here from the homework. Okay? So there's actually more than one way to express an answer, okay, to these inequalities. All right? So the typical way to express the answer to the inequality is by, like, writing out or graphing it, okay? There's one other method here I'm going to show you. I'm going to put it in a different color. I'm going to put it in green, okay? So hopefully it'll stand out a little bit here. And that's called an interval notation, okay? So when you want to use an interval describes like, I don't want to say it, like a list of numbers or a range of numbers that you would consider for an answer, okay? So to write this inequality in an interval notation, you would still start at the number 5, okay, like this. And since we're going to go greater than 5, okay, since we're going to pick numbers that are greater than or equal to 5, that means we want to go towards positive numbers here. This little arrow at the end, what does that mean it goes to? What does that arrow point towards? Right there. The arrow means it goes on and on and on to what number? Infinity. Yes, infinity, okay? And so what we're going to say here is 5, comma, infinity, like that. Okay? And then we're going to group this. We're going to use some grouping symbols, okay? And there's two main kind of grouping symbols we're going to use. For infinity, you will always, always, always end or put infinity with a parenthesis, either an open or closed parenthesis, depending on where it is. In this case, it's on the right, so we're going to open it, okay? What does a parenthesis mean? It means you don't include that number. Infinity can never be included because it keeps going, right? It never stops, okay? However, 5, should we include 5 in our solutions or should we not include 5? According to the inequality, what should we do? It's not a trick question here, folks. Should we, according to our inequality, is 5 a solution or is 5 not a solution? It is, right? How did you know, Carson?
It's on the line.
Yeah, it's on the line. It's got the dot on it. It also says equal to there, okay? So yeah, we're going to include it. And to include a number, you put a square bracket like that. Okay? So this is the equivalent interval notation right there. That's interval notation right there. Okay? So let's try number 5. Okay? Number 5, this one says b is less than -10. So in this case, I'm going to start at -10, but now because of my graph here, it's pointing to the left. What does that approach? Is it going to go to positive infinity as well? Alex, Carson, is this going to go to positive infinity as well? Ah, okay. See, but you know what, Dylan? You still help because then everyone else started answering correctly. So I appreciate what you said. Even though it was wrong, I appreciate it. Thank you. Because at least you said something, okay? You're right, it's not. What's going to go to? If it was going to the right, it'd go to positive infinity. What's this one going to? Negative infinity. So, that was exciting yawn. Okay, so negative infinity is on this side of -10. So we're going to put the negative infinity here. Okay? So instead of going -10 to negative infinity, that doesn't make sense. We're going to go from negative infinity to -10. Okay? Since negative infinity is infinity, what kind of symbol, what kind of grouping symbol should I use here? Do we ever include infinity? Nope. So we're going to put parenthesis. And then here for the -10, is the -10 included in our solutions? Yeah. It's not. How can we tell? Is there an equal to here? No. Is there a filled in dot here? No, it's not included. So we're going to exclude it by putting that parenthesis around that. So then, that's the interval notation for that. Okay, let's try another one here.
Yeah, I see that negative next to the infinity, right? That
right.
Negative sign.
Okay. Pay attention here, folks. I'm doing this for a reason, right? We're going to be using this later, so it's going to be super important you try and understand it right now, too. But then we'll get to the word problems here in just a second. All right, number 7. All right, if you want to bring it over to Ms. Mulcahy, she'll get it from you, Mark. Thank you. All right, number 7. All right, this one we're going to put that 6 down, okay, but the arrow is pointing to the left, which means we're approaching what number? We're going to go far, negative what? What are we approaching? It keeps going, so it's going to go to negative infinity. Okay, and again, negative infinity is less than 6, so it goes to the left of 6. What kind of grouping symbol should I put here with the infinity? Parenthesis or a square bracket. Parenthesis, because you never include infinity. And then 6. Do we include 6? Is it included according to this? No. No. Open circle. Not equal to. Interval notation. Okay. Okay. We're going to keep going here. We're going to do 9, 11, and 15 as well because I think we still need to practice. Okay, it sounds like we're not quite getting it. I'm going to start calling on folks too because I feel like people are purposely avoiding me, and I hate being avoided. So here we go. All right. All right, so number 9. All right. Shepard, where do our solutions start according to the graph here? You'll pass. Shepard, you got to start answering here sometime, bud. Okay. Matt T in the back. What do you say? Where does our inequality start here? What number? Starts with a 9. That's right. So we're going to start at 9. Okay. And then it's going to go to the right. So what is it approaching? To positive infinity. So this time, because infinity's bigger, it's going to go to the right now of the 9. Okay. Do we include the 9 or not? Don't answer that, Matt. I'm going to go to somebody else. But thank you, Matt. Let's go to Dylan. Dylan, is the 9 included in our solutions according to the information here? Yes. How can you tell? What gives it away here besides Carson told me so? What? Guys, this is Reagan, please help us.
It's closed.
Yes, it's a closed dot. Or what's this symbol mean? Equal to. So it includes it. Okay, folks, you can get this. Really, it's not awful. I mean, I'm not making this up. I mean, it might sound like I'm making this up, but I'm not. I promise. Okay. Yeah, the filled in circles and stuff like that. Yeah. Okay, let's try this next one. Number 11. We'll go to Mark. Now, Mark, I know you weren't here, but where does our inequality? Where does our solution start? You can look here, or you can look here. Where do our solutions start? At what number? Mark. At 1. Okay, so I'm going to start at 1, but then it goes to the left. Now, I'm going to get someone to help you, Mark, because you weren't here for this part, I don't think. So let's go to, Caden, help us out. From 1, we're going to the left. So what is that approaching? You got it. Good job. And we're going to put it on the left-hand side here because negative infinity is to the left of 1 there. Okay. Now, Mark, back to you. Is 1 included in our solutions or not?
It is.
How can you tell? Look what we have here. It's an open circle. So does that mean we include the 1 or not?
We do. Not.
If we don't, because it's a hole, right? It's empty there. Same thing here. If you look at the inequality, does it have an equal to there?
No.
It does not have an equal to. So 1 is not included. So parentheses. And then do we ever include infinity, folks? No. So parenthesis. No. Okay, last one. This is your last chance to get it, and then we'll have to try again maybe later. Okay, I'm going to take a break. We'll go to the word problems, all right? So last chance. Here we go. All right, I'm calling someone. I hope we get some good answers here. Let's see here. All right, I'm going to go to, if you don't know, that's okay. Tyler L. All right, Tyler L. Where do our solutions start here according to our answers?
-4.
-4. You got it. Great job. And then Tyler, it goes to the left. So that means it's going to go to what? If it keeps going to the left forever and ever and ever, it's going to go to what? Yeah, so in this case, negative infinity, because it keeps going to the left. Okay, so negative infinity is to the left of -4, so I'm putting it to the left of it here as well. Okay, we never include infinity. And then Tyler L., last question for you here. It's an open circle here. It doesn't say equal to, right? So should we include the -4? No. So parenthesis there for the interval notation. Okay, all right. So that's your brief introduction to interval notation. We're going to see that more. And in fact, I think because we need some practice with it, some of these word problems we're going to do intervals for as well. Okay, so I'll put that away. And I've got some paper for you. Paper. Don't be upset. I try not to be. It's better for your health if it doesn't. Okay, we're going to look at some inequality word problems. Woo!
Yeah, guys, you guys are going to have to really put your brain power on. That's easy. Give me the paper. Calculator.
see it in her eyes. Okay? We'll do a few. How about this, Dylan? We'll do a few together. And then maybe if I feel like you're getting it, because, sometimes I worry, I want to make you get it. If I feel like you're getting it, then maybe I'll let you guys, work on some together. Okay? But here's the problem, too. People ask me, Mr. Wig, can we work together on this? I'm like, yeah, you can work together on this. But then they go and sit next to each other, and they're together, but they're not working. That's a problem. That's a problem, okay? So let's see what we can get done here, and I'll think about it. All right, so inequality word problems. Folks, I know, look, word problems, they're rough, right? I mean, some of us just find, difficulty with this, right? We just had a quiz on equation word problems, and now we have to look at inequality word problems. The answer is yes, all right? That's part of the expectation of this class. I can write inequality from a word problem and then potentially solve it if need be, okay? Now, the directions here, what do they ask us to do? Because it's important we understand what we're being asked to do. Represent each of the following as an algebraic inequality. Okay? Represent. You know how to do that, right? Each of the following, these are the problems. Algebraic inequality. What's going to make these algebraic, you think? What's going to be in these inequalities? What makes something algebraic? It's got what?
Pickles?
No, Miss Mulcahy, not pickles.
Okay,
Someone help out Miss Mulcahy. She doesn't know. What do algebraic things have in them? Letters, right? Variables. Thank you. And numbers. Yes. Okay. So here we go. Represent each of the following as an algebraic inequality. Number 1, x is at most 30. At most?
You guys have notes.
We just talked about that. What is it? Okay, so it's got the equal to, less than or equal to. Wow, Carson remembered. I pulled it up here, though, too, just in case we didn't remember. But yes, x is at most 30. Okay? X is at most 30. Okay? X is at most 30. Wow, we're missing a line here. I'm going to draw one in. Okay? The sum of 5x and 2x is at least 14. Okay. So, greater than or equal to? Well, let's see here. At least is at least greater than or equal to. So, greater than or equal to 14. What does sum mean, Carson? Sum means to do what?
Total.
What? Total. So, what operation is that? That is?
Addition.
Yeah, addition. That's right. Thank you, Carson, though. You did a really good job there. Okay. Yeah, I know. Throwing his voice. Okay. And thank you, Mark, for raising. Oh, did you raise your hand, Mark? Yeah. Thank you for raising your hand, too. Appreciate it. Okay. Number 3. The product of x and y is less than or equal to. Wow, that's really nice. They just literally say the symbol to us. So what's the symbol for this one? Yeah, it gives it to us. Okay. So less than or equal to 4. Okay. Mark, how do we write the product of x and y? What does product mean? What operation is that? Not division, multiplication. So it'll be xy. Right? X times y is less than or equal to 4. Okay? X times y less than or equal to 4. All right? So keep these handy. I have to move mine out of the way because I got to move my paper up here. Okay? But you have yours handy, hopefully. Okay? So you can see it. Okay. If 5 times a number is increased by 4, the result is at least 19. Find that least possible number that satisfies these conditions. Okay? So, let's see here. How can we write that? We're going to go to Matt S. Matt S. 5 times a number would be what? 20. Just what? How do we show 5 times a number? Don't give me any symbols just yet. Just tell me what is 5 times the number mean? 5x. Yep. Is increased by 4. So 5x. Hold on, Matt. Do you agree? Plus 4? Plus 4. Okay. Is at least. Okay, now we're looking for the symbol, right? So is at least. Which one of those is at least? Go ahead. Good job. Yes. Okay. And then what should I finally write on the other side? Perfect. Great job, Matt. Well done. Okay? Good job. And thank you for the help, other people, but let's let Matt do it on his own if we can, okay? Okay, cool. Matt, well done. I'm going to go to somebody else then. Let's go to Carson. Your number's up, bud. Carson, can we solve this? What's the first step going to be here to solve it? Subtract 4 from each side. 19 minus 4 is 15. Okay, Carson, thank you. I'm going to go to somebody else. Reagan. Oh, man. We're playing hide the calculator back there. Okay, Reagan. What do we do from this step? 5x is greater than or equal to 15.
Oh,
Should we do
5
that?
divided by 5 on both sides.
Divide by 5 on both sides. You got it, Reagan. Very good. X is greater than or equal to 3. Okay? So, we've solved inequality, but have we answered the question yet? The question says, or we're asked to find the least possible number that satisfies these conditions. According to this, what is the least possible number that satisfies these conditions? 3 is the smallest, right? 3 is the smallest one that works in that inequality. So 3, in this case, is our answer. Okay? 3, in this case, is our answer. Of course, we answered the question there. We weren't asked to graph the solutions. We weren't asked to write the solutions in interval notation. So I'm going to hold off on doing those because we weren't asked to do that. I'm going to stick just to what the directions ask for right now. Okay? All right. Number 5. Let's take a look here. The sum of twice a number and 5 is at most 15. What are the possible values for the number? Okay? So let's go to Erica. So Erica, the sum means we're going to be what? Sum, adding, good. Twice a number. How do you write twice a number? Shh, please, guys, give Erica a chance. Twice a number. So twice means what? 2 times, and then a number. So what are we going to want to use here? Well, so we don't know the number, right? So we'll use like a variable, x or something like that. So 2x, and it's the sum of 2x and 5. So 2x, you said it was addition, so plus 5 there. Okay. Is at most. Is at most. We'll go to someone else there, Erica. You did a fine job setting it up there. Mark is at most. Is at most, right? That's our inequality symbol, right? Just like is at least was greater than or equal to, what do you think is at most is going to be? So what inequality symbol will we use? So can someone help out Mark here? What's going to be, what is at most? Less than or equal to. You got it. Okay? And then 15, right? Is at most 15, so less than or equal to 15. So Mark, you had the right idea. It's the greatest it can be. The greatest it can be, then you must be less than, this must be less than or equal to that 15. Okay? All right. So now we're going to solve it. We'll go to, let's go to someone we haven't heard from yet. Catherine. Catherine, first step here. What should we do to solve this inequality? Minus 5 on both sides. You got it. 2x is less than or equal to 10. Okay? And then, Catherine, I'm going to let you keep going here. What's the next step?
Divide it by 2.
You got it, Catherine. Well done. Divide both sides by 2. X is less than or equal to 5. Okay? So this question asks, what are the possible values for the number? So here it's just anything that's what? Less than or equal to 5 there. Okay, that's all the possible solutions to that inequality. All right? So we could show this, we could leave it like this. Right? We could also graph it to show the different values that would solve this inequality. I'll start with 5, 6, 7, like that. 4,
So when it says,
and then 3.
when it's asking you the question, what are the possible values? Don't you have to graph it to show, or can you just leave it in x is less than or equal to 5?
That's a good question. I mean, I feel like both of these are supposed to show the possible values for the number. So I would be okay with either one there, but I'm going to do both just because. Since we're graphing here, okay, what kind of dot should I put on the 5? Filled in or open? Filled in because of the, go ahead, Liv, because of the equal to there, right? And then which direction are we going to shade, Liv? Are we going to go to the left or to the right? It's x is less than, so which way is less than 5? To the left. Okay, just like Beyonce. To the left, to the left. Okay.
To the right.
that's not the song now. It's to the left here in this case. All right. Now, I'm also going to show you the interval notation too. Okay. We started at 5. It's going to the left. So what number is it going to be approaching? Negative infinity. So that's to the left of 5 here. Do we ever include infinity? No, not for our purposes. In fact, I think you never really do. Okay. Do we include the 5? Liv said to do it, right? Fill in the dot, so it's a square bracket there to include the 5. Okay, so 3 different ways to show the possible value of the number, but you had to solve first. Okay. Are we getting the idea here? Let me check through this. I think, yeah. So I'm going to give you guys the rest, up through number 10 there. Only up through number 10, okay? So go ahead. I'd like you to work on those for the remainder of class, okay? And Dylan, I don't think we're quite ready to work together, so I want you to stay where you are, please, and work through number 10, okay? And that'll be that. That's going to be your homework, okay? So don't do both pages.
Which one's number 10?
6, and then 7, 8, 9, 10. So finish the first page.
I couldn't figure out 7.
Okay, I can come and help you.
So 6 to 10
I just couldn't figure out how to
6 to 10 is homework. Classwork for now. If you don't finish it, homework tonight. But if you work well, there's a very good chance you won't have any homework tonight. 6, no, just the first page.
motion.